Hi, I'm Bob Van Til, Chair of Industrial and Systems Engineering here at Oakland University, and welcome to the Product Lifecycle Management Lab in room 568 Engineering Center here in the Oakland University's Industrial and Systems Engineering Department. This room is our primary computer lab for the Department of Industrial and Systems Engineering. It is used by a multitude of courses in our program. Some courses will use it only for a small assignment or two. Other courses will make heavy use of various softwares available in this lab. One of the prime users of this lab is our Introduction to Industrial and Systems Engineering. That course is taken by all engineers in our core program. So we have anywhere from 150 to 200 students per semester going through this lab. Based on the number of 18 computers, this is about a 600 square foot lab. Obviously, we can't bring them all in on set times. So what we do with that lab, and we're running that lab actually, is we run that semi-virtually. These students can actually remotely desktop into these computers and virtually work on the labs. And we'll get a mixture of both. We'll probably on the simpler labs, a vast majority will do them virtually. And the little bit more difficult labs will give them a higher percentage of students actually coming to work on them here to get TA assistance. It's also taught, we also offer 5 special 2-credit courses that run 7 weeks that are actually taught inside this lab on various Industry 4.0 software, PLM software tools we report. And so those particular classes do have a scheduled time where they'll come and they'll spend a couple hours in this lab holding the actual class. It's a very hands-on, focused class on various software tools. This lab contains many softwares with a heavy focus on Industry 4.0 software. Some of the tools available on these computers would be the plant simulation software for discrete event simulation, Arena also for discrete event simulation, the Jack ergonomic software from Siemens, Siemens Process Simulate software, which is used for robotics and for manufacturing cell design. PLC software from Siemens is on these computers, along with Minitab. MindSphere IoT software from Siemens is also available on these computers, along with other general tools such as Office for presentations and writing reports and making spreadsheets. We are working also to add SAP software to this lab for our ERP course. Now we're going to take a look at some of the Industry 4.0 prime software tools we have in this lab and use in various classes. The first one is our discrete event simulation tool, Plant Simulation. This is from Siemens. It is a very popular tool in industry. General Motors and FCA, this is their prime design tool, and Ford extensively uses it also, along with a lot of other non-automotive industries. What you're seeing running here in that video is a student project last year from our PLM Applications Throughput Simulation course. That still picture there is the conveyor system located next door in our Scharf Computer Integrated Manufacturing Lab. This 3-dimensional running of the animation, mostly for display purposes, and then it'll switch back to the 2-dimensional version where real engineering work goes on in discrete event project. Again, this tool is used everything from our EGR 2600 course to give our sophomore level engineers an introduction to some advanced tools and some concepts they're going to see later. We use this through several other courses up through the capstone design course. In fact, this semester, 2 of our capstone design projects at Broza and at Siemens are using this tool right here. The next tool we're going to take a look at is our ergonomics tool, Jack. Now this particular animation shows a nice animation of the capabilities of Jack. Jack is a full ergonomic tool. It'll do stress analysis on all the joints. So as this mannequin is doing this process, you can measure stresses on wrists and shoulders and elbows and back and analyze that for repetitive stress or even disruptive kind of injury because you exerted yourself. This will also load in and do collision avoidance. And so that is a CAD front end of the car. As the mannequin is reaching down in there, this will tell you if that gap is too narrow and that you're actually passing your arm through metal. And of course, the mannequin can be male or female. And this is about a 50% male here. You can change that to a 95% male and the mannequin will grow in size, or 5% female and it'll change to a female and decrease in size. And you can analyze them for various behaviors. So we use this in several courses. Again, the students are introduced to this tool in our sophomore level EGR 2600 class, where they really aren't doing ergonomics, but they kind of see the tool. They get to play with it a little bit. They get a look ahead at some of the future courses. Heavily used in our ergo course, and we use it some in our senior design projects.